This is Unit 4, Lesson 6. So we have a little warm-up here that's kind of a flashback to something that you guys have done before, that square root property. So we're going to look at the second one, number 2. So this left-hand side, this is something that's known as a perfect square trinomial. That's what it says over here. So we're going to factor the left-hand side down, and then you can see it's set equal to 20. So if we factor that left-hand side down, we are looking for what multiplies to 9 and then combines to a -6. So we can start, with our x times x, when we have equals 20 on the right still, we're not going to touch that. Multiplying to +9 and adding to -6, we know that they're both going to be negative, and that would be 3 and 3. The reason that we call this a perfect square trinomial is because these are identical, so we can write them in their squared form. We can take this and write it as x minus 3 squared. So this looks an awful lot like the ones that we solved a few lessons ago where we had like x squared equals a number, because we can solve it the same way. So if this left-hand side has a square like this, the way that we can solve it is by taking the square root of both sides. So we can take the square root of the left, take the square root of the right. And the only reason we were able to do this is because this factored down in this particular pattern, and the reason this factored down in this particular pattern is how the 6 and the 9 connect to each other. Let me show you that real quick. Half of this -6 is -3, and when I square that, I get 9. So because of that perfect pattern, it's going to end up factoring down like this. So this, I take the square root of both sides. When I take the square root of the left, I just get an x minus 3. Kind of like taking the square root of just an x squared gives me an x, so that's similar. And then 20, first of all, I know it's going to be plus or minus because I'm solving an equation. The 20 itself is not a perfect square, but remember I can split it. So I split it into 4 and 5. So the square root of 4 is plus or minus 2, and then I just leave the square root of 5 like this. So for my final answer, what I do is I need to get the x by itself. So I'm going to add the 3 over to the right-hand side. And it can't combine with this because it's not a like term. So I have just the 3 on my right-hand side and then plus or minus 2 times the square root of 5. And hopefully you remember from some radical stuff, we cannot add these two together. You can't add the 3 and the 2. You can't subtract the 3 and the 2 because the 2 is attached to a square root and the 3 is not. So they're not like terms. So it looks a little funny, but we actually just leave our answer exactly like that. All right, so using this idea that I just told you, this special pattern between the 6 and the 9. So the pattern is if there's something that's half of this and also the square root of this, we're going to be able to put it into this perfect form. So half of 6 is 3. The square root of 9 is 3. Since those match up, it factors down into this pattern. So our goal is to turn all these ones below into something that does factor into that pattern. So we are going to look at number 3. We've got a long step-by-step process here. I'm going to walk you guys through all the details. So number 3 right here, step number 1 is rewrite with the x squared and the x on the left and then the constant on the right. So here, this constant, the 56, needs to move over. So I will write it as x squared minus 18x, and then I will subtract the 56 from both sides so that I have x squared and x on the left, and then just the constant on the right. So that's step 1. Number 2, divide both sides by a. And that's really only if there is something here. So if you look here, that's technically just a 1, so I don't have to do anything. We will see problems where we do have to do that step, so don't forget about it. Number 3, complete the square by taking half of b and squaring it. So we've done this process before. It was when we were turning quadratics into vertex form. So we actually saw it earlier in this unit. So we start with this middle term right here. It's the -18. We're going to take that and chop it in half. When I take half of that, I get -9. Then I'm going to take that -9 and square it. And when I square that, it gives me 81. Okay, so that's, we said, complete the square. So you always take half of that middle term and square it. And then what we're going to do is add it to both sides of the equation. Because the left-hand side needs it so that it fits into this perfect pattern, but you can't just add something to the left. You have to make sure that you're keeping things balanced by also adding it to the right. So I will have x squared minus 18x plus 81. So that left-hand side is now a perfect square trinomial. And because I added 81 to the left, I have to also add it to the right. Step 4, factor the perfect square trinomial. So this left-hand side. Factor that down. I am looking for what multiplies to 81 and adds to -18. And remember, if we did this last number right, it should be the same thing. Like multiplying to 9 and adding to negative 6 was 3 and 3. So it should always be a repeat. So multiplying to 81, adding to negative 18 would be 9 and 9. So instead of writing it out twice, I'm going to write it in its squared form, because that's the whole point of this stuff, is being able to write it in that squared form. The right-hand side, when I add these together, I get 25. So now it's in the same form that I was in up here, so I can solve it this way. So step 5, take the square root of both sides. So square root, square root. The left-hand side is now just an x minus 9. And a little reminder here, it says this will create two cases, because the square root has a positive and a negative value. So the square root of 25 comes out evenly, but don't forget your plus or minus. And solve both equations. There's going to be two equations here because I have a plus or minus. So let's add the 9 to the other side. So I have 9 plus or minus 5. So I have to do addition first, then subtraction, and I get two different answers. So 9 plus 5 gives me 14. 9 minus 5 gives me 4. So two different answers means I should be writing my set notation like this. So I have 4 and 14, two different answers to my equation. All right, on the next page, we're gonna look at number 5. So I'm actually gonna keep putting the step-by-step back on the screen just to remind you. So step number 1, rewrite in this form, x squared, x on the left, constant on the right. And if you look, it already is in that form, x squared and x on the left, constant on the right. Step 2, divide both sides by a. So I do actually have to do this here because a is a 4. So I am going to divide both sides by 4. So on the left-hand side, I have x squared minus 2x. The right-hand side is just a negative 3/4, and I do have to just leave it like that. We're gonna be working with some fractions here. Step 3, complete the square, taking half of b and squaring it. So I take this term right here, I take half, which leaves me with a negative 1. Then I will take that negative 1 and square it, and that gives me positive 1. So that's the number that you add to both sides of the equation. So I have x squared minus 2x, I add 1 to that. And then on the right-hand side, I have this negative 3/4, and I'm gonna add 1 to that as well. Okay, so left-hand side, step 4, factor the perfect square trinomial. So the left-hand side will factor down. We wanna know what multiplies to 1 and adds to negative 2. And remember, if we did this right, it should be the same number. So that's negative 1 and negative 1. So instead of writing it out twice, I write it in this squared form. That's the whole point of this stuff. Right-hand side, negative 3/4 and positive 1. We can think of this as like 4 over 4. Give it a common denominator to make this a little bit easier. And when I add those up, I get 1 over 4. Step number 5, take the square root of both sides. We should have a plus or minus. So square root here, square root here. This is now just an x minus 1. And we have our reminder that this is supposed to be a plus or minus, and take the square root of 1/4. All right, so square root of 1 is 1. Square root of 4 is 2. And then finally, to solve this, I'm gonna add 1 to both sides. So I have 1 plus or minus 1/2. So if I add 1/2, I get 1.5. Might as well do it in a decimal if you want. And when I subtract 1/2, I get just 1/2. So you could do decimals, fractions, mixed fractions, improper fractions, whichever you prefer. So we'll write our answer in our set notation. Just to show you, we can do decimals or fractions. So 0.5 is 1/2, 1.5 is 3/2. So decimals or fractions, whichever you prefer. All right, we're gonna do 2 more. We're gonna do number 8 next. So step 1 was to make sure the constant is over here, which it is. Step 2 is to divide by this number right here. So divide everything by 3. So this is now just an x squared minus 10x, and then 69 divided by 3 is 23. Next, we do the completing the square step. So I take this middle term, cut it in half. That gives me a negative 5. Then I take that negative 5 and square it. So that gives me 25. So this 25 needs to be added to both sides of the equation. So I have x squared minus 10x, I add it to the left. And then to make sure we're keeping the balance, we also add it to the right. Next, we're gonna factor this left-hand side. So we wanna know what multiplies to 25 and adds to negative 10. So that would be negative 5 and negative 5. So I can write it as x minus 5 squared. Quick trick is that this number is always half of this number. So that's a really easy thing to look at. It's always half of this number. It's also always one of the square roots of this number. Add these together, we get 48. Step 5, take the square root of both sides. Left-hand side is now just an x minus 5. Right-hand side starts with a plus or minus, and then I need to take the square root. 48 is not a perfect square, but I can break it into 16 and 3. So the square root of 16 is plus or minus 4. The square root of 3 just gets left behind under a radical. And finally, add 5 to both sides. This is going to look like our very first problem did, because we can't combine this or simplify it, because some stuff is attached to a radical, some stuff is not. So they are not like terms, so I cannot combine those at all. Let's do one last one. Let's do number 9. So step 1, get the constant by itself. So I'm going to subtract 43 from both sides, which will look like this. Step 2, divide by a. Here a is just 1, so I don't have to do anything there. Step 3, complete the square. Start with that middle term. Cut it in half, which gives me 6. Then you're going to take that 6 and square it. That gives me 36. Then finally, this is a long step, I take the 36 and add it to both sides of my equation. Okay, so we've got 36 on both sides. Step 4, factor that left-hand side. So multiplying to 36, adding to 12. Remember, a quick trick is that it's always half of that middle term. So half of 12 is 6. And if you FOIL that out, I promise you would end up right back here. Right-hand side is a negative 7. Step 5, take the square root of both sides. So take the square root here, square root here. When I take the square root, I get just an x plus 6. I know my right-hand side starts with a plus or minus. And then the negative 7. This is taking us back to a few lessons ago where we had negatives under the square root, and we know we get an imaginary from that. So 7 is prime, but I can separate the negative 1. So remember, the square root of negative 1 is this imaginary number I, and then the 7 gets left behind because you can't break it down any further than that. So last step, solve and simplify. So you just subtract the 6 from both sides. So we have the negative 6 first, and then plus or minus I root 7. Definitely can't combine those because this is real, this is imaginary, this has a square root attached, so these answers just stop right there.